Hi guys, so today we will talk about our project number 3, which is entitled the bouncing counter. So for this project we were given certain limitations, and the first limitation was to create a counter which will count from 0 to 99, then from 99 to 00. So this counting needs to happen immediately after 99 was reached. So it's like 99, 98, 99, 99, 98, 97, 96 downwards and upwards. So it needs to bounce from upwards and downwards. So for this circuit, we have created certain parts. We have created 5 parts for the implementation of the circuit. So for the first part, we first created two 4-bit asynchronous circuits made out of JK flip-flops. So asynchronous means that the output of the first flip-flop will be the clock input of the second flip-flop. So for the ones digits of our circuit, we created this. This is the ones digit of our circuit, these 4 flip-flops. So we have A, B, C, D. The A is our most significant bit. And then we also created this 4 serves as our asynchronous JK flip-flops for the tens digit. So these are the 4. And then we need to set our next limitation. So for our next limitation, we were required to only show values of 0 to 9. So to show values of 0 to 9, we must modify the reset or the clear circuit, which is this pin of the asynchronous JK flip-flops. So from this truth table, we found out that the value should be A prime plus B prime plus C prime. So A prime plus B prime plus C prime. I mean A prime plus B prime C prime. So this was created, connected to the reset pin, and in the bottom also connected to the reset pin. Then after that circuit, we need to create the up-down function shifter flip-flop. So this is our up-down function shifter flip-flop. Now what this means is that if the circuit resets, this 10 circuit, if the circuit resets, then the up-down circuit flip-flop will have a value of 0, and it means will have a value of 1, and that means that if the shifter or our up-down reset flip-flop or our function shifter has a value of 1, then the overall circuit will proceed to the down operation, in which it will count down from 99 to 0. So again, once this set of flip-flop resets from 9 to 0, then this flip-flop will activate, and what happens next is that this flip-flop will trigger the down initiation. This means that the circuit will experience a downward counting. So that's the purpose of our function shifter. Next part is our code converter circuit. So now that we have two operations, we have the up operation and the down operation, we need to create the values for our operations. So for the up operation, we have these values from 0 to 9 expressed in binary. So as we can see, 0 to 9. So in BCD, this is our binary bits. For the other part, which is the down value, we need to get the reverse of that function. So from 0 to 9, we should make 0 as 9, 1 as 8, 2 as 7, then 3 as 6, and so on and so forth. So to do that circuit, we implemented a code converter. Now this code converter was made up of a BCD to decimal, this part BCD to decimal, and decimal to BCD. As you can see, the pins are connected. The 1 pin is connected to the 9, the 2 pin is connected to the 8, the 3 pin is connected to the the 1 is connected to the 8, the 2 is connected to the 7. This means that it will perform the necessary conversions for our down circuit. This means that if our up function receives a value of 0, our down function will show a value of 9 instead of 0. So that from those outputs, we proceed to the next part of the project. The next part of our project is called the output selector. So now that we have two outputs, namely the up output and the down output, we are now looking towards creating a circuit that will serve as the control, so that we will know what to display on our 7 segment. So this is our shifter circuit selector, consisting of the shifter, the NOT, and gates and OR gates. As we can see, this is that part of the circuit. This is that part, selector circuit. Then after that, we have our 7 segment decoder and display circuit. So after our output is selected, it will be displayed to our 7 segment. So this is the face of the 7 segment display, of course. So we used a decoder circuit from binary to our 7 segment, so that the overall circuit will experience a seamless transition. So let's see if it works. We will set it at 200 hertz so that we can see the changes in the circuit. Okay, let us play the circuit. So it's now counting up. The circuit is counting up to 99. We will wait. So as the circuit is counting up, our shifter circuit is still at the 0. So it still chooses to display the counting up values. So the normal values is displayed. Now as the circuit approaches 99, our shifter, it chooses to display the down values. So these are the down values from 99 up to 0. As you can see, there is a certain delay in our circuit since the computer makes it hard to process the circuitry of this experiment. But in a real life scenario, the circuit will have a seamless transition from each state. So that shows my project number 3. Thank you for listening and have a good day.